speaking of good to go, let me go ahead and get started. I know many of you out there. My name is Steve Ruddles. I'm the warning coordination meteorologist with the National Weather Service. And joining me today is Corey Rothstein. Corey?
Hi, I'm Corey Rothstein. I'm a meteorologist here at the National Weather Service in Springfield, and I'm glad to be talking with you at our fall webinar series.
Speaking of that series, we have had one of the webinars that the Weather Service created just to connect up a little bit more with our partners. Of course, during these times of COVID, we've all had to change gears a little bit, and we've not been able to get out into the communities like we usually do. So we wanted to conduct these fall webinars in order to kind of give you, yes, some new information, maybe remind you of some of the hazards. But as we get further and further into COVID, this becomes one of our major ways in which we can communicate information with you all. Of course, the presentation today is going to center around the fall secondary severe weather season. Some would refer to it as the secondary tornado season. We in the Ozarks aren't quite part of the United States that see these events every year, which is probably a good thing since they can be so deadly. But on the other hand, because we don't see them every year, maybe we don't plan for them as much as we need to. Okay. So again, my name is Steve. This is Corey, and we're going to go ahead and talk about when it comes to severe weather. When it comes to severe weather during a time of year where you don't expect severe weather. Maybe when it comes to the time of year in which events increasingly occur after dark. All of these things together do lead to a particular challenge, maybe a hazard, and occasionally fatalities. In order to get started, I do want to make sure that everybody recognizes the fact that yes, you are muted, but we do want to have your questions. We want to be able to answer your questions today as opposed to when the next outbreak occurs during a winter event. So I'll draw your attention to the GUI, the webinar GUI that lists questions. If you'll click on that, I'm going to ask you to tell me which winter severe weather event do you remember the most? It may have affected your community. It may have left a lasting impression due to either the damage or maybe a fatality. But I'm curious, can we get you to go ahead and in that chat or in that question box, tell us which winter severe weather event do you remember the most? I'll give you a couple minutes. I see a group answer from the Missouri Basin, the December post-Christmas 2015 event. That was a doozy. Thank you, guys.
Steve McLean says Christmas flooding a few years ago as well.
Yep. And Terry Lane, Ice Storm 2015. Terry, you're going to like our upcoming seminars on winter weather in that case.
Megan says January 2008 tornadoes. Same with Patricia.
And so did Patty. Yep. Brett, no surprise that you remember the Fort Wood event. Mike Edwards, Thanksgiving tornado 2008. Mike, you've got a pretty good memory.
Paul Newman says she wasn't here, but 88 to 90 in Seattle, there was a big storm somewhere in that time frame as well. So,
absolutely. Okay, guys, that gives us all the ability to communicate during the course of the presentation. So please ask your questions, provide your generalized comments. We want this to be as interactive as virtual webinars allow us to be. When I'm speaking, Corey is going to monitor the chat room and the questions. He might ask you a couple questions during the course of the presentation, and then we're going to switch gears. When he speaks, I'll have a chance to monitor it. So again, this really is for you guys, and we want it to be two-way. So please ask us those questions. All right, so go ahead with the presentation. When it comes to severe weather, we talk about April, May, June. Why in the heck are we talking about tornadoes during the course of the winter months? Well, look at 2002. Look at the Lucky Lady Trailer Home Park in Chesapeake. Consider the New Year's Eve event that hit Fort Leonard Wood and Rolla. And then, of course, the Leap Day tornadoes that affected Cassville, Kimberling City, Branson, Buffalo. These are all events that have left a lasting impression in the need to prepare for severe weather events here in the Ozarks. Here's a particular one that occurred. Some of you noted this one, January 2008. I heard about this when I was in a cruise ship down in the Gulf of Mexico. I couldn't believe the news reports that were coming in. 33 tornadoes in January. Who would have thought? Well, it's something that does not happen every year, but it is something that we have got to be ready for. Now, sometimes these events are relatively quiet in nature. They don't get quite as much news attention. But just look at the number of events between 2017 and 2020. These are all damaging events. In some cases, they cause fatalities. One thing I do want to bring to your attention is the time of day. 7:03 p.m., 8:04 p.m., midnight, 1:30 in the morning. And, does this give us a added impact, an added threat from these storms? And I hopefully by the end of the presentation, you have a better feel for why do we need to prepare for these events. Again, they don't occur very often, which in itself is a challenge. Now, if you want to look at where we're at, climatologically speaking, during the course of 2020, the black line here, kind of in the middle, goes up through the end of September. And compared to the green line, which is the average number of tornadoes in a given year, we're running just a little bit below normal. And maybe that's a good thing because of COVID. And of course, this is nationwide. I do want to draw your attention to the top line, the red line, so to speak, and that's the maximum, that's the record. Look back at the cool season, the December, January, February, March. Our black line this year kind of followed in many ways the pattern provided by that maximum. The fact is, folks, we never know from year to year just how bad the season is going to be. We're not going to cover a whole lot in this particular presentation, but one of the things that we are concerned about when it comes to the cool season, again, October, November, December, January, February, one of the things that we are concerned about is a global circulation that we call La Nina. Many of you probably heard of El Nino. Well, La Nina is kind of the opposite in terms of temperature patterns. Quite often in the La Nina years, especially here in the Ozarks, we do see an increase in number of tornadoes, and our long-range forecast is calling for that La Nina to continue. Looking at a little bit more as far as patterns, well, if you look at all months throughout the course of the year and where we go from year to year, we again see a lot of annual differences. A lot of years, few tornadoes, a lot of years, a lot of tornadoes, but you can see the pattern has slowly increased. Now, these are EF1 or F1 tornadoes up through EF5 or F5 tornadoes going back to 1950. Check out the bottom line here. The slope of the November, December, January, February tornadoes, the so-called cool season tornadoes, the slope of that green line has increased faster than the overall trend in the number of tornadoes. So obviously that is a concern. If you want to play the odds, this time of year we start thinking about a white Christmas. And here in the Ozarks, we've got roughly a 10, maybe 15% chance on any given year to see a white Christmas, something that everybody seems to want to have. If you consider the graphic on the right side, this is the probability of a tornado watch roughly over the Christmas period, over a 3-day period at either side of Christmas. We have about the same chance of seeing tornadoes around Christmas as we do with the probability of a white Christmas. So again, these are things that we have got to be prepared for. It doesn't happen very often. I've said that now a couple times, and there's a reason for that, because we've got to just get it in our mindset that these events do occur. So let's take a look at normal. If you consider a month by month number of events, starting in January and ending in December, right there in the middle, that second row of months is where we do obviously see the greater number of events here in the Ozarks. You do have a smattering of tornadic events during the course of the year, though, and that is something that in particular Corey is going to hit. But I do have a graphic here. I've got a movie that I think I'd like to show you that will probably provide an even better indication of what it means to be in the Ozarks. So I need to get to my graphic. I'm having a hard time for some reason. Why is that not popping up on me? Oh, you know, you go through practice and these things never happen in practice mode.
Well, Steve, while you're looking for that, let me put out a poll because you kind of briefly touched on it, but I want to see if people were paying attention. I'm going to put out a poll and ask what month of the year do we witness tornadoes in the Ozarks? Feel free to comment and we'll take a look at that once all of your stats have come in. A little over half the people have voted so far. It looks like overwhelmingly everybody says every month, which would be the correct answer.
Great answer. It shows how skillful all our partners are across the Ozarks. And Corey, did that video pop up?
Let's take a look here. The poll is still in the screen. Still seeing the one where it just says tornado probability, Steve.
Oh my. Okay. Well, it's a great video. Trust me. Basically, what you're seeing on the video, if I can do my best ability to communicate it, imagine starting down in the Gulf of Mexico. There's a lot of oranges and a lot of reds as the number of tornado events starts to increase. Of course, what's going on during that time of year, the jet stream is further to the south. During the course of the year, then, come the springtime, we're starting to see the number of oranges and reds, the number of events starts to move up into the Ozarks. April, May, early June, our tornado season. Come July, come August, the jet stream has moved into the northern tier of the United States, up maybe into the Great Lakes. And then as the jet stream starts to slip further to the south, the number of events starts to increase again in the Ozarks, settling back down into Dixie Alley, that so-called area from Mississippi across to Alabama, maybe into Georgia. This is a known cycle. The jet stream, as it rides to the north, increases the threat of severe weather, and then as it goes back down to the south, it takes that risk of severe weather with it as well. Okay, so the probabilities we know are a chronological pattern. It just gives us an opportunity to kind of look back and base our expectations. Corey?
All right, thanks for that intro, Steve. What we're taking a look at here next is Kyle Perez and I, he's another meteorologist at the Weather Service here in Springfield, did a case study looking back at all of the days throughout the years of 2008 to 2019 to take a look at what kind of Storm Prediction Center convective outlook days we've had throughout the year. Convective outlook days, again, are just assessing the probability or the coverage that you're going to have severe weather throughout that given day. As you'll notice with the legend down at the bottom, you have your none, which would just be a day without any thunderstorm risk, your general thunderstorms, which won't be any severe weather expectations. And then as you go right on the scale, getting higher up into the warmer colors, a higher probability of seeing severe weather or multiple threats of severe weather during the day. And you'll notice across the entirety of the year, about half the time we don't see any sort of thunderstorm threats over our portion of extreme southeast Kansas and southwest Missouri. But you'll notice about a quarter of the time we're starting to get into that area of seeing severe weather. So about one of every 4 days, somewhere across our area has a potential to see some sort of severe weather, whether it be hail, wind, or tornadoes. Next slide, Steve. To take another look at this, this is just showing the counts over that 2008 to 2019 time period. Again, you'll see our busiest days throughout the year, especially the ramp up in the spring, are going to be April, May, June, even into July for severe weather. And then as we get into the fall and the winter, the cold season, it starts to drop off, but you'll still notice that we do see the potential for severe storms even in the months of October through February, even though they don't occur as frequently. And like Steve said earlier in the presentation, you do still see some of these higher end events about every few years. And even last year, for example, in October, we had an event with multiple tornadoes as well. Next slide. This is just another view of the monthly SPC outlook threats as relative to the number of days as a percentage. So again, the busiest percentages are going to be during your springtime and our summertime here. But even looking down into October, November, December, even back into January and February, you're still getting on the order of about 10 to 20% of the days, or so about 1 in every 10 to 1 in every 5 days, where we could still see some sort of severe weather potential over our area. All right, next, Steve. And again, to highlight that threat, we have a monthly plot of tornado warnings that we've seen throughout the year. Again, seeing that peak in the springtime, which we expect with more instability and the higher shear. But in the winter and even in the fall, you'll notice there's still that secondary bump, which is why we refer to it as a secondary severe weather season, regarding those few events that we do see in November, seeing 37 tornado warnings in the last 12 years. And even in January, that bump that shows that we do get some significant events, even if they don't occur that much. And a lot of that is coming from the January 2008 event with a lot of the tornadoes that we had there. All right, next. Okay, got back to you, Steve.
And I'm gonna take back control there for just a little bit. I want to talk a little bit about that big event, that January 7th and 8th event back in 2008. Yes, we saw 33 tornadoes. An added situation, 23 of which were after dark. We will get into storm mode, the type of events that we see here in the Ozarks. But the storm mode started out as being supercellular. And one of the things that we can see from supercells, of course, are strong, if not violent tornadoes. Well, along with that rotation that leads to the tornadic threat, sometimes we see very large hail. And in January of this particular year, we did receive a 5-inch hail report. The other thing about this event, the wave after wave after wave of tornado events. Webster County in particular, Bob Crump, I mentioned you earlier. You know, this was an event that started out during the afternoon and then continued well into the evening hours, well into the nighttime hours, after midnight, in fact. And Webster County, I point you guys out because of the number of tornado warnings that the Weather Service issued for Webster County. You know, this is an event that is rare, obviously, but it is an event that, you know, with the added threat of, with the average threat of events occurring after dark, we've got to take a look at this situation. And as meteorologists with the Weather Service, I see some broadcasters here, as emergency management directors, maybe if some of our Weather Ready Nation ambassadors are present today, we all have got to highlight not only the fact that this thing is occurring in January, Not only the fact that we're seeing supercells followed by squall line tornadoes, but we have got to do our best, whether it be our on-air capabilities or the Weather Service products that we type up and send out, or the thing that we all can do, which is let people, our friends and family know via social media, that a lot of these events are occurring after dark. And I did find one study that was done back in 2010. More than half of the tornadoes that occur between October and February that are EF2 or greater. Now, these are strong tornadoes or greater. They're occurring after dark. I just cannot say this enough, that the threat of tornadoes during the wintertime, but in particular, the threat of tornadoes after dark, really provides kind of an added emphasis on the danger associated with these events. Okay, and again, as we showed you earlier, the threat is just increasing. Now, just kind of bring back everybody's memory towards this event. Started out as supercells. We see that going up the I-44 corridor. We had the lead supercell go through the Springfield area, a third supercell, fourth supercell, and then it kind of started having clusters of cells, merging clusters of cells back to supercells. So this was a really extreme event from the standpoint of not only seeing a tornado during the wintertime, but the supercells, and then finally more tornadoes associated with that squall line that moved west to east across the region. And then note the light drizzly rainfall at the tail end of that. That's something I'm going to get into at the tail end of this presentation. Not only are we dealing with the potential for severe weather during the event, but let's take a look at the aftermath as well, because we know that's where the emergency management community really gets going during the response phase. So again, hopefully this brings kind of the memory back to just how bad an event, because in my opinion, this is probably the most atypical event that we can see here in the Ozarks. Wintertime tornadoes, wave after wave after wave. I mean, that's a rare event no matter when you look at it. But supercells becoming squall clusters, and then with a squall line moving across the area, it just goes to show you that we have got to be aware of what Mother Nature can throw our way. Okay. Charlie, I see you did have a question. Will the Springfield National Weather Service provide some type of verbiage to that effect? Sharing the data is one thing, however. If we have the National Weather Service icon, it carries credibility. Charlie, one of the things the social scientists have told us is it doesn't do any good for just one entity to provide information like that. One of the things that the Weather Service is striving to do is share information pre-storm, during the storm, and then after the storm with our partners, such that we can all speak from one voice. And that's what the social scientists have said is so very important. Good question. Thank you. Corey, back to you. And I think we have another poll question, don't we?
Yes, we do. I will share that right now. And the poll question here is going to be, what makes cool season events so dangerous?
And Corey, as you get set up, I'm going to go ahead and give you the results of the poll here in just about a minute or so. We're seeing several of you guys have submitted your answers. Again, if you go to the right-hand side, you should have the ability to ask your questions. Having several people still come in. Okay. Well, I'm going to go ahead and close here with 92% saying they occur after dark, 4% due to low CAPE, high shear, low confidence, and 4% looking at the radar signature associated with those events.
And they'll be right on many of these things. Actually, everybody that answered anything besides duh, it's winter is correct. So I'll get more into that here as we go forward in this presentation here, if you don't mind going to the next slide, Steve.
Okay. When it comes to the cold season severe weather events, it typically starts with the normal ingredients that we see from those thunderstorms. We need moisture. That's the energy source. We need instability to get those updrafts to go up into the atmosphere. And then we need something to start that system to get organized and ultimately provide large scale lift. If you look at the springtime, anytime we start looking at thunderstorms, these are the ingredients. If you look at the summer, the fall, the winter, anytime these ingredients come together with enough moisture, instability, and lift, we are going to start to forecast thunderstorms. Now, what's the difference between a normal thunderstorm day and a typical severe weather day? One of the things that meteorologists can laugh about is anytime that you start to put things over on top of each other to the point by which you can't see underneath it, that's when you start to forecast a severe weather event. Well, in this case, we have a lot of ingredients. Again, moisture, instability, lift. And if you consider first off, during the winter time in particular, you've got a lot of low level, moist, unstable air coming in from the Gulf of Mexico. The difference though between the spring and the winter, these cold season events, is that low level jet is pretty shallow. It's bringing that warm, moist air in, but it's pretty close to the ground. Of course, we know thunderstorms go 10 miles up into the atmosphere. So we're talking in the lowest level of the atmosphere, okay? But again, warm, moist air. It's the reason why, boy, you can go outside, January 7th of that event, and you can almost feel like there's something wrong. You can almost get a feeling innately that the atmosphere is setting something up for the potential for severe weather. We feel the humidity, something we normally wouldn't feel in January. On top of that, literally on top of that, there is the jet stream. Now again, normally this time of year, the jet stream has been pushed down across Texas, across the Gulf Coast states. Occasionally though, we'll have a storm system push that to the north. And once you get the upper level jet on top of the low level jet, we're starting to result in two of those three primary ingredients. We've got the low level moisture in place, and then we've got the upper level jet that kind of helps with organizing that upward vertical motion, the upward lift. The situation that we have different though from the spring and the winter time deals with the amount of instability. And Corey's going to hit this hard in here in just a couple minutes. A lot of times we have the lifting mechanism. We certainly have got the upper level jet, and we've got that low level, shallow, unstable air layer, and we get updrafts start to form. But there just isn't enough instability for that updraft to go straight up. Instead, the strong winds aloft tends to push the top of the storm, in this case on the picture, off to the right. And it results in a sheared storm that the rainfall gets pushed away from the updraft, so the storm system can't quite get all that organized. The rotation is certainly there within that sheared environment, but the top of the storm gets pushed off to the east, the rainfall gets separated from the updraft, and the thunderstorm doesn't last very long. In fact, it dies after a short period of time. Okay, so kind of with that in mind, let's take a look at some events that have occurred in the past, and also to the answer to that poll question that you had. Corey?
Thanks, Steve. Yeah, and I've got 5 different things, some of which were highlighted in the poll question, some other ones that were grouped together. Steve, if you mind listing those here on the slide set. So I'll be going through all of these and focusing on them as we go into the other slides. Just want to retouch on them briefly here. You're gonna have your high shear, low instability. Again, with these storms that Steve talked about, that can relate to a lot of uncertainty as to whether storms develop or even last long enough to become severe. Your storm mode, again, we'll be touching on what are mini-supercells and squall lines, which can be some of the more high-end producing storms in the cold season and tend to produce our most severe weather. Also touching on radar returns at longer distances. As you get further from the radar, you're scanning higher into the storm. It makes it more difficult to see some of those features that might indicate that we're going to have severe weather. Number 4 becomes speed of storm movement. As Steve talked about, we'll have, with the upper level jet overhead, usually some stronger forcing. These storms tend to move faster in the fall and can also limit your lead time with any severe warnings or tornado warnings that we'll put out during that time of year. And finally, as everybody, or the majority of everybody talked about in the poll, will be the time of day and the factor of having severe weather at night. Next slide, please. So as we talked about before, a lot less instability tends to happen during the fall and the winter than it does in the springtime when we see our most severe weather. You'll see that the updrafts typically on the order of about 20 to 30,000 feet. Now that might seem like a lot, but during the warm season, our storms tend to get twice as tall on average because of the warmer atmosphere. And normally with those smaller updrafts during the cold season as well, you're going to see that those become more sheared with the higher shear aloft, and that can tend to kill your updrafts, as Steve mentioned. Whereas the warm season ones tend to be able to fare better with that shear due to being wider updrafts that can protect them from the environment and the atmosphere, as well as making them much taller, which gives a much larger threat for hail, and as well as winds when you have downdrafts on those storms. Next. And again, yeah, just to reiterate that too much shear, though you need shear for storm development and organization, too much again can shear the storms apart. Next slide, Steve, thanks. For those of you who have been in some of our spotter or speckle courses, you'll notice that this may look familiar as well. This is just a diagram of what a typical squall line would look like. On the leading edge, you have your updraft of the storm going up into the higher reaches of the storm. And then on the back side of the storm, you'll have your downdraft where all your rain and your winds might be coming out of. And then right on the interface between those two, near the surface and the front edge of the storm, you'll have your gust front, as you can see in the plan view image on the left. And that's where you'll see a majority of your wind with any squall lines that come through. Next slide, please. And to briefly touch on a mini supercell. The only difference really between a mini supercell and normal supercell is going to be the size of the storm itself. All of the other characteristics you see here, like the mesocyclone, the rotating updraft on the back side of the storm, and then the downdraft on the front side of the storm, are going to be similar whether it's a regular supercell during the spring or a mini supercell during the colder months of the year. Next. Getting back to what I was talking about with the radar returns at longer distances, oftentimes when you're within tens of miles of the radar, you're able to scan relatively low in the atmosphere, maybe 1,000 to 3,000 feet above the ground. And into the storm at those locations, you can see these different features like the mesocyclone I talked about before with the mini supercells when they're close to the radar, which can help be a good precursor for putting out warnings for tornadoes or any sort of other severe threat we're expecting. So you might get a little bit more lead time with that closer to the radar. But as you get further from the radar, maybe 40 to 60, even more miles away, you start scanning pretty high up into the atmosphere, into even the higher portions of the storm. So sometimes in those farther distances, you may be overshooting the rain core entirely, and you might not see many of these features. So sometimes the severe and tornado warnings might have less lead time because we're not able to see as many of these features that we would normally see in a storm when we're issuing severe thunderstorm warnings and tornado warnings. Next. And to highlight the speed of storm movement, I just want to show you the event of a squall line that came through on December 1st of 2018. You'll look on the left side, you do have the radar image of the squall line over, we got Newton and McDonald counties at 12 a.m. Of course, this is going to be at night too, which I'll touch on
Okay, we may have lost Corey there for a second. Okay. Could I get somebody to chat something into the text box to see if you can hear me? Okay, thank you very much. I'm going to go ahead and continue for Corey here. The big issue associated with speed of movement between, let's say between midnight and 1 a.m., let's consider just how fast these thunderstorms can move. Think about it. If you're in Greene County, up here near Springfield, how far off to the southwest you have to consider storms to be that might be affecting you. Moving at 60 miles per hour, again, after dark. This gives a real great challenge when it comes to getting the public to respond to these events. So if you look at the time of day, we know for the most part, when it comes to our typical severe weather events, the late afternoon, early evening hours is where we have to be most prepared. But if you start to look into the September, October, November timeframe, that time of day starts to change. Look at September, 6:45 to 7:45. That's 6:45 a.m. to 7:45 p.m. So just a huge time frame for a relatively few number of events. October, same thing, 7 a.m., 7 p.m. November, the 6:30 a.m., 5:15. At least those are during the daylight hours for the most part. So, when we look at historically tornado warnings during the fall, we really have got to anticipate evening into the overnight hours, and then even in the early morning hours, which in itself is a kind of an odd thing to consider. Now that 6 a.m., 7 a.m., 8 a.m., 9 a.m. time frame, this just doesn't happen. Well, because it doesn't happen, the public is not necessarily prepared for these events. Corey. Corey, we can't hear you. All right, give me a second, Corey, and let me make sure I can unmute you.
All right, can you hear me, Steve?
I can, thank you.
All right. Sorry about that, guys. I seem to have briefly lost internet connection there. I blame the Wi-Fi for that one. I don't think that was user error, but thanks for covering for those previous slides, Steve. As far as time of day, again, I wanted to highlight the just the timing of the fatalities. You'll look since the beginning of 1950, we've had a total of 243 direct fatalities from tornadoes throughout the year. 158 of those were Joplin, and to kind of highlight the time of day, I didn't include Joplin in this graph here. So in reality, what the graph is showing is the 85 fatalities we've had from tornadoes by time of day without Joplin included. And to show that, you'll see a lot of these occurred during the later afternoon hours beyond 4 p.m., really through mid-evening, about 8 p.m. But even with the majority occurring during that time of day, you'll notice that even some of these are occurring at night. You got four fatalities around the 11 to 12 p.m. hour. And then even in the early morning, there's a few fatalities as well. So that's why I wanted to highlight with this slide. Could you go to the next slide, Steve? I wanted to focus a little bit more on the fatalities that occur during the cold season months that we've been talking about. And you'll notice in this graph here, I've highlighted the time of day for each of the 22 fatalities that have occurred in the October through February timeframe. You'll notice that 22 fatalities is about a quarter of the fatalities that was on the previous slide set. If you exclude what happened in Joplin, which was a tragedy. But as far as number of events, we've had 13 events for those 22 total fatalities. The yellow bars in the graph will show you the time of day that it occurred during when the sun was up. Meanwhile, the gray bars would show you when the sun was down during the winter. And you'll notice that majority of the fatalities are occurring after dark, with really only 5 of the 22 occurring during the day. So that highlights again the concern of having severe weather occurring majority of the time at night when you can't see these storms coming in. All right, next, Steve. And to highlight all of what I just talked about, I wanted to go through a few case studies. The first one would be the Aurora, Missouri squall line tornado that went through on the night of November 30th into the early morning hours of December 1st, 2018. And you'll recall this one did actually have a fatality with it as well. Next. So you'll notice with the squall line is in McDonald County back up into Newton County. On the left side of the screen, you'll see the radar, and on the right side of the screen, you'll see the velocity images with the green colors being towards the radar and red colors being away from the radar. Steve, are you able to see the loop going? It seems to have paused for me. Okay, there we go. Main thing I wanted to highlight is you'll see that there's a large number of reports that occurred with this storm as it quickly moved through from the southwest to the northeast across portions of Missouri. And with that, again, seeing a few tornado images showing up as well. The tornado report right there in Aurora was as the storm moved through. If you look at the velocity images, there really wasn't any tightening of the circulation until a few minutes before that tornado report actually occurred in the southern side of Aurora, where that fatality occurred at a motel. So the lead time on this was very, very brief, maybe on the order of 2 minutes or less. So given the time of day being at night, unless you were situationally aware of the possibility for tornadoes, a lot of this would have struck without much heads up. All right, next, Steve. This is just the tornado path itself. After we did a survey of it, again, it was an EF1 tornado with winds of 100 miles per hour. It was very short in duration, only occurred for about a half of a mile. And again, unfortunately, we had that one fatality as it struck the motel. But even so, even with it being a short tornado and not entirely strong, it is still a deadly possibility during the fall months. And this squall line as a whole actually produced 7 tornadoes, as Steve talked about earlier in the presentation, during the hours of 12 to before 2 a.m. So everything with this squall line occurred at night. Next. Second event I wanted to talk about was the Holberg, Missouri Mini-Supercell tornado, which actually occurred earlier in 2018 in the month of January on the 21st. All right, next. You'll notice there's really not any sort of organization to the storm, maybe a little bit of rotation with it southeast of Freestadt. But once you get right south of Holberg, you'll see that there was some rapid intensification of the storm itself, even getting a little bit of a brief supercell looking structure to it. But it was really hard to see, I'll have this look through again, really hard to see further to this southwest before the tornado occurred, much of any organization to the storm. And then again, quickly spinning up before that tornado report came. And again, only seeing a few minutes of lead time because of how quickly the storm formed, and then getting sheared apart and weakening quickly after the tornado was briefly touched down in south of Holberg. Next. Again, we had another EF1 tornado with this. Path length was about 1.5 miles, a pretty narrow tornado, only about 75 yards wide. Luckily with this, there were not any injuries or fatalities, even though it did occur again during the late evening, which would have been in after sunset. So luckily, the only damage that we had was to a few outbuildings, an irrigation system, and a few ski boats, as well as some trees. So we were very, very lucky to not have seen any fatalities with that. Next. And I'll kick it back to Steve here to talk about the El Nino and its possible impacts, or La Nina and its possible impacts on severe weather this year. Steve?
Okay, all right. Hey, I appreciate that. And I also have an added opportunity today. We've had our climatologist, our office climatologist, some of you know Gene Hatch, and Gene has checked in here today. And Gene, I've got a couple slides here. Can you kind of talk in general about La Nina versus El Nino? We've already said that uh, we do typically see a few more tornadoes occur during La Nina years compared to El Nino, and kind of just talk a little bit about why that is. So I've got this slide and I've got this one for you as well. So Gene, go ahead. Gene, you're self-muted. There you go.
Yeah. Okay, there we go. Well, thanks, Steve. I appreciate you giving me a little bit of chance here to talk. One of the things that Steve had mentioned is the potential increase for tornadoes during La Nina winters, which we are expected to be in through this winter and into early next spring. One of the potential reasons for that is there's the potential, looking back historically during La Nina years, that we generally tend to see slightly warmer temperatures or a lean towards warmer temperatures during the winter seasons because of the La Nina conditions. Now, that's not always the case. We have had winter seasons in La Ninas where we just haven't had a whole lot of severe weather activity. However, as you can kind of see, looking at the left-hand side of the chart there, during the La Nina years, there is a pretty good signal for increased tornado outbreaks during the winter months during La Ninas, and then continuing into the spring as well in the center area there. So, with that La Nina, that does have the tendency that increase the probabilities that we could see some severe weather outbreaks during the winter months.
Okay, thank you, Gene. I appreciate you pointing those things out. So let's kind of wrap this all up together with one final piece. Of course, the Weather Service is going to let you know when severe weather possibilities exist. So not only for winter weather, but flooding, for tornadoes. We're going to highlight that in the hazardous weather outlook. We're going to be putting it into a product that we make available online called the Situation Report. The watch comes out indicating conditions are favorable, not necessarily they're going to occur, but they're favorable. When the individual storms develop and we feel like they are going to be severe, they are going to be tornadic, of course, we're going to issue warnings. Those warnings are going to go out in a variety of ways, and those are ever increasing. Going back to this idea that social scientists have said, for people to respond, there has to be a consistent message that arrives in that family. Now, again, think about this. This is occurring at 9 p.m., 2 a.m. You know, these are storms are moving real fast and not during a time in which we expect severe weather. So that consistent response, whether it be from the broadcasters, whether it be from you and I via our Facebook or Twitter account, these things become very, very important. So the storms occur. Unfortunately, there's a possibility that severe weather has caused some damage. One of the things I want to touch upon is the continued impact of COVID on our operations, on our ability to help the communities out there during severe weather events. You know, we're concerned about the safety and welfare of our staff, just like you are concerned about the safety and welfare of your folks. And we will be there for strong and violent events. But come wintertime, a lot of these events are pretty weak. Maybe they're even difficult to find. So one of the things that the Weather Service is asking for our emergency management partners is to please let us know as soon as you think you've had a tornadic event. Maybe take a map, do some simple annotation, take a picture of it and send it into the Weather Service, whether it be email or to our cell phone numbers, which we shared with you in the past. And that at least will let us know what has occurred. This is especially valuable in real time. Let's go back to the day that Fort Leonard Wood and Rolla got hit. There was a tornado that occurred down close to, or at least on the on Table Rock Lake. It had occurred during the very early morning hours. By those emergency managers giving us the heads up that a tornado had touched down during that event, it increases our confidence in issuing warnings downstream. So if you can let us know this information early in the event, not only will it allow us to use our social media capabilities, work with the media, et cetera, to prime our partners downstream, but it also helps with our decision making. Okay. Now, the other point I will ask is, if you do go out and do a survey, we want to recognize the fact that there are a couple things that go on with cool season tornadoes that makes it a little bit different than those surveys that you do come spring and fall. So let's consider a couple things. Let's consider first tornado debris signatures. You hear us talk a lot about that in NWS chat. A TDS has occurred, or a TDS is evident on radar. Well, what is a TDS? If you consider the ability of the radar beam to go out both this direction as well as this direction, we have the ability to take a look at cross sections of what's being thrown up into the sky. If it's nice and round, all right, we're going to assume it to be rain, maybe some snow, maybe even some hail. But if that cross section is dramatically different on the X or Y plane, we're going to infer the likelihood that what the radar is picking up is debris being thrown up into the sky. Okay, and if we feel like it's being thrown up to a certain height, we're pretty confident it's been due to a tornado. It does not mean we know where that debris has actually occurred. And again, we go back to our spiders, we go back to the emergency managers to tell us exactly where that damage is. But often particularly the fall, when there's a lot of leaves on the ground, these are going to get lofted up real quick by that tornado, and it might result in the detection of pretty small tornadoes. So please consider that when we start telling you that there is a TDS indicated on NWS chat. The other thing, I'm going to go back to this idea that emergency managers are going out and doing surveys for the Weather Service. Because of the amount of shear within the atmosphere, the winds are pushing that thunderstorm much faster during the winter months than typically during the spring months. So typically, due to that rotation and that fast moving storm, the debris on the forward flank of that tornado is going to get pushed off, and it's going to be noticeable being pushed downstream with the direction that storm is moving. The return flow, and I'm going to use the graphic here in this case, the return flow, the wind direction going towards the back of that tornado is going to be much weaker because we add in the speed of the movement of that storm to the intensity of that tornado. So in this particular case, this was an event that resulted in a pretty good rotational axis within trees. But as you got across this road, there was a mobile home that was unfortunately destroyed and pushed off to the east, and another mobile home on the back side of that path, the back side of that rotation, pushed back to the west. Now that's a pretty good indication that a tornado has occurred. But again, in the wintertime months, most of these tornadoes are moving faster, and most of them are weaker, so it might just look like there's been some wind damage. So from an emergency management perspective, if you guys go out and do surveys, just a keen eye to detail might make all the difference in allowing us to determine if indeed a tornado had occurred. Okay, and again, with your help, I wanted to draw your attention to one of the seminars that we did back during the early summer months. Emergency Management Storm Survey Training is available on our YouTube channel, as will be all of the fall partner webinars that we put on during the course of this series.